It is my pleasure, and I would ask you all to help me welcome John Waters to the stage.
Thank you very much. Thank you. Good afternoon, I'm John Waters, and probably you guys can suspect at this point I'm not Don Bridges or John Mackerel as in the little presentation sheet. So if you guys do see their names still on the little grading sheet, you can put it low. I don't mind, my name's not on there, so it'll just look bad for them. Also, we have another sign-up sheet in the back of the room. If you guys are interested in receiving a recording of this presentation, you can go ahead in the back there, sign up with your name and email, and we will get that off to you. I would probably wait till the end to see if this presentation was actually worth it. Also, I will probably not go the full hour. I know this is the last block of the day, so I'll probably be giving you guys some time back. I will probably end up going through this a lot quicker than I have by myself. So kind of going over what we're going to cover today, the agenda, a little introduction on me, also on JANA, what's structured content, what is structured data, where it comes into the product lifecycle, the benefits the organizations can gain for this, and kind of a real-world example illustrating how we can kind of follow that digital thread throughout utilizing an integrated product support strategy, and then a kind of quick overview over the S-Series introduction, which is another standard for integrated product support. So a quick overview for JANA, that's who I'm here representing. This picture is not from a TV show, I forgot, what is it? Mad Men. It's not Mad Men, this is actually the founder of JANA, Arthur Nyland, and his unnamed associates created JANA in 1973, and this is kind of an engineering organization that has spread across the globe, focusing on engineering data, technical publications, reliability, manufacturing, the whole gambit. And then a little about me, John Waters, I'm the senior consultant for JANA, U.S. Army veteran. I have 20 years of experience, cover both civil and defense domains, particularly focused on technical service relating back to the operational and documentation standards, and especially for integrated product support strategies. And specific to aerospace, I chair the electric air vehicle sub-team, and I'm also the civil aviation representative for S1000D. So, walking in here, what is structured data, structured content? I'm going to use these terms interchangeably, though there are a few nuanced differences. Structured data is more formalized, a little heavier, formatted data structures where we're looking at JSON or XML structure, and then structured content, we kind of think of that, relate that more to textual based, right? This is where we're managing content that's more text related, not so much into the formatting. Structured data, structured content, much like this picture, is where we're taking this unorganized group of data, collecting it and turning it into bite-sized, easily manageable bits of information by applying either a standard or some predefined model. And utilizing the structured data, the structured content, this allows us to reuse data across the organization, across different business functions, and also be able to recall this information a lot quicker. And a lot of times we get really caught up in this idea of structured content, structured data. Sounds scary. But this is what we're already doing in our organizations today. How many people or how many organizations here are doing FMEA assessments during the product development, the failure modes and effects analysis? You guys are creating structured data. You're already doing it internally. This is not something special. This is not something new and divine. You guys are already doing it. It's simple that we can just now make it work for us, right? Make us more efficient. The structured data is also the cornerstone of our modern engineering. This is what enables the management of the data, driving design, driving production, driving manufacturing, and also providing the maintainability instructions for our products. It makes engineering data not only accessible, but it makes it actionable. And that is probably one of the biggest key takeaways from this, is that structured data, structured content has to be accessible, and it has to be actionable. We have to be able to get it, and we have to be able to do something with it. Otherwise, we're just introducing waste into a process. This is just adding more confusion, more layers, more bureaucracy, everything else. This is not helping us. And another key attribute of structured content and structured data is the fact that it enables interoperability. So now we can use these data sets across the different business functions, across the organization, because it is structured. We know what to expect. We know how to gain it. We know how to gather it. So now we're able to use it across the board. And without this standardization, we lose any chance of interoperability. And so moving on, where does this fall into our product lifecycle? And kind of utilizing the product lifecycle from an IPS size, we have 5 phases: preparation, development, production, in-service, and disposal. And so taking the first example, preparation phase, this is where we're starting our design. This is where the basis of our structured content, our structured data is starting. We're defining our system requirements, our operational requirements, our use case. What does the operator need to do in the field? How can we design a product that fulfills those requirements? This is the initial set, how we're going to do it, and this data set is driving lifecycle cost analysis, predictive maintenance, and so our support models, and going into our development phase. And this is where, excuse me, this is where we're starting to conduct our engineering testing, implementation and configuration management, and also going through our gated reviews processes like SRR, PDR, CDR. And we're creating these data sets now because this is driving this data, we're driving this digital thread throughout this entire product lifecycle, moving us into the production phase, where we're finally making the product, right? We have now validated, we have tested our design, we're meeting our design requirements. We are now going through and producing this product, going through support reviews, final acceptance reviews, and finally we get to my favorite portion, the in-service phase. And this is the most critical phase, in my opinion, for structured data and structured content, because now you have operators in the field utilizing your equipment. And this is the most important time to make sure that the data is also accessible and actionable, because people's life limb depend on this. And then finally, we move to the end of the life cycle where we get to decommissioning, disposal. We're looking at how to recycle parts, recycle the product, how do we finalize the support. And what I want to focus on today will be the in-service phase. How does that digital thread look for an in-service product based off an event and how can we follow that digital thread? Before we get to there, I want to go over a few key benefits to where structured data really comes in to the picture here, or how it provides benefits back to the organizations. The first one being operational efficiency, right? Structured data, structured content streamlines the processes, making vital information readily accessible and easy to understand. This is crucial for minimizing downtimes in the field and ensuring that the operations continue to run smooth. That same logic is used for improved decision making, because now the structured data allows the organizations, because the data, again, is accessible, it's actionable, we can now use it to make informed decisions faster, respond to field events faster, and limit the impact to the customer. Another key benefit from structured data is our ability to create predictive maintenance, right? This is probably a topic I could talk on all day. I think this is a cornerstone of any product support strategy and a successful life cycle. But you need structured data to be able to predict maintenance. You need the historical data coming out of the field. You need to be able to assess it, and you also need to be able to make it actionable, right? That same trend, that same logic goes down to our training modules. Now that we've come out with these procedural requirements to maintain the product in the field, now we're able to drive the training requirements based off our tasks that we have created now to prevent or to mitigate those failures in the field. And that only improves our customer support model, right? So now as we're gathering all the data, all the stuff, this is now coming through, we are able from our support side to be able to grab that information, to be able to put it back out to the customers quick and fast. And the last, compliance and safety. Oops, it did not go. Compliance and safety, because all of us here, or most of us here are in some type of regulated industry. And regulated industries and regulatory compliance demand good record keeping. And that is where structured content and structured data come in. Because it keeps everything in a consistent form, a searchable format, and this is how we keep the regulators happy and off our backs. And this logic can be applied from design documentation all the way to shipping invoices for export control. Any questions at this time? No? We'll keep rolling. Now transitioning into our real-world event. I would normally pick on Boeing, but I think Boeing's had a little bit of too many people picking on them recently, so I'm going to go over to the rail side and talk about a derailment on the Norfolk Southern Railway in February 2023 in East Palestine, Ohio. It affected roughly 38 cars derailed. 11 of those cars were carrying a hazardous material that leaked out, started a fire, causing an evacuation radius of a mile, affecting over 2,000 residents in the area. And of course, now we have the entire track now is stopped. Operations have ceased, not only for Norfolk Southern, but for anyone operating on this railway. And how many organizations here, when you have an event in the field, start going through like root cause analysis, right? Going back and investigating, how did we get here? And one of the things that I started to talk about, jumping around a bit, is that when we talk about this predictive maintenance, we talk about this at the product development side of the FMEAs, when we start thinking about how can this product fail and how can we mitigate it, that's the same thing that Norfolk Southern Railway did. They started that same digital thread because they started with their product and condition health, or the product health and condition monitoring. And so when they started looking and investigating this accident, there was a lot of sources of data coming in. Even one of those sources of data was a video capture from somebody's backyard camera that caught a red-hot bearing on the train as it came past. So now this even directed them now to where they know, there's a few other things, but to where this failure occurred. So part of their preventative maintenance program, Norfolk Southern said, hey, bearings fail. They fail in every industry. They're a problem in every industry, but we have to implement some kind of preventative program to prevent and to mitigate these failures in the field. And so Norfolk Southern did exactly that. They implemented these hot bearing detectors so they could assess the temperature of the bearings while the train was going down the track. So nobody had to stop. It was automatic. There's no effect to the operator. And the hot bearing detectors would send an audible warning to the operator to let them know, hey, something's going on. You have to stop. You have to check. Something's going. And so because now they've created this, hey, this is our mitigation technique to this failure, we also have to come up with the operating thresholds. Where are we going to operate within this window? And so for Norfolk Southern Railway, the hot bearing detector thresholds were above ambient temperature, or related above ambient temperature, and it was 10 degrees Fahrenheit that night, clear and dark. And so we look at the operating thresholds between 170 and 200 degrees Fahrenheit. It's considered a hot bearing, but not critical. You have to stop and inspect the bearing. If there's a difference in temperatures of greater than 115 degrees Fahrenheit on the same axle, again, it's not critical. You have to stop and inspect. But if it's greater than 200 degrees Fahrenheit, you have to stop and you have to set out the rail car, which means that now, and if there's anyone in rail, please help me. But if it's stopping and setting out the rail car, this is when they're coming out, the mechanics are coming out, taking off the bearing and replacing it right there on the track. And so we look at what the readings, right? So we're looking at this data set coming in from the field, this digital thread. And so now we're getting the readings from the hot bearing detectors. And we can see that when it crossed the second one, it was within the operating threshold. There was no problems. However, by the time that it got to the very next detector, the temperature had already passed that critical threshold by the time that it announced an alert to the crew. It was too late. So by the time that they've already started the initiating and stopping the train, the bearing failed and the train derailed. So we know now that these thresholds, what we initially thought based off our maybe potentially theoretical data, doesn't work. We now have direct impact from the field that is telling us, hey, we have to go back. And where do we go back to? the very beginning, back to that design organization, back to the engineering organization. So now this digital thread is coming back around to the beginning. So now we got to think about how, again, can we mitigate this potential failure? We can look at things like consideration for an advanced brake system. And coincidentally, Norfolk Southern Railway did that. They put out a safety memo that required the use of electronically controlled pneumatic brakes on any train car that was carrying hazardous materials. However, due to a rollback on some of these safety rules, this was one of the things that was not determined to be necessary. And so it was never installed in this car, and now we can look at how critical really making sure that these risk assessments, thorough risk assessments, and making sure that you're analyzing and identifying all the risks of the program to that product are being identified when we're making considerations or determinations like this. Again, we have that definitive proof that the thresholds do not mitigate the risk. So now we have to go back and we have to start this rework again. To whether that's changing the thresholds that trigger the alarm, to the rate that we're capturing these, or even lowering the thresholds that now we're going to inspect even earlier, right? We're not going to get to this place. We're not going to get to that level. We could even take in this data sets now that we're collecting all this data and even add it to predictive maintenance models, simulation data within our PLM instances. Even going back and adding more hot bearing detectors, going back and designing a sensor into the bearing. How do we mitigate these failures? And looking at O2, examining the servicing schedules from overhaul schedules, lubrications, how does this data trend, how does this data work for us? Because it needs to be actionable. And one of the key data sets that I think is one of the most important is the mean time between failures, right? So as we're looking between how often is this component failing? Is this value getting larger between failures? Because if it is, that means we're doing a good thing. We're on the right track. Because now there's more time occurring between each individual failure. However, now, if this value starts to close and we start seeing more failures and this mean time between failures starts getting smaller and smaller, we have to go back. We have to reinvestigate. We have to make a change because it is not working. So now that we made a change at the design organization at this design level, this is going to play out into a fielded environment, right? Because our technical publications, our operating instructions are simply external communications of our internal design documentation. There's nothing else. And so now that our designs have changed, this thread and this data trend must also go out and also affects the fleet support. So now that we've changed our designs, this is going out and now it's going to affect our documentation, our procedural contents, how the people are going to operate this, how they're all going to operate the product, how they're going to maintain the product, how they're going to service anything. Now this is going to come out through our documentation. And this is even through rapid response to the field events through service bulletins. And now that we changed the procedural content and how we're going to operate and how we're going to maintain this product, now we have to go back and reevaluate our training program. Did the changes that we made affect how the training environment is going to operate and how it's going to look? And then, of course, one of the most important data sets within this fleet support or within the product support side is the maintenance records. How do we know what was done on this product? We have to make sure that the data is available so we can go out and see, hey, was those upgraded brakes actually installed on this train or not? Was it on this car or that car? This is the importance of those maintenance records. That way we can go, draw them out, and be able to use them for the benefit of the organization. So now that we talked about how this works in kind of a real-world scenario and how we can follow this digital thread, and we see how it works within the design organizations and through the fleet support, but how do we manage this data? And a lot of it mostly is managed now through our product lifecycle management software. So our team centers, our Windchills, our Minervas, our Eris. These programs allow us to utilize and maintain these data sets within a centralized repository so it's easy to call and be able to use across the organization. And because now that it's accessible, it's actionable, it means that we have structured data. And so now this can also be interoperable. And so now we have the advantage to use this across the entire product field. So now our PLM instance now becomes a collaborative platform. So now you have the different key stakeholders involved, and everybody's able to use the same data sets. We're not siloed. And this is one of the critical pieces of that. And where we can draw some of this coming in is going to be from one of the applications where we talk about standardization of data is through the application of what's known as the S-Series. S-Series how many people are familiar with integrated logistics support? ILS. Nobody? Nobody heard ILS? All right. Now my whole speech is over, so no. Integrated product support. So how do we constantly think about the product from design side all the way through obsolescence? And this is one of the many ways that we can standardize this. This came out of the Department of less from the military side back in the 90s when we started having to make sure that we had the right people in the right place with the right equipment, with the right manuals at the right time. And so through this application, we have S1000D, which is our technical publication development side. This is structuring our data into smaller bite-sized pieces to where we're able to reuse the data over product instances, over project instances. So let's say that you have a forklift and you have 90% commonality between 5 different variations of that forklift. Most of the time, a lot of organizations approach this and create 5 different manuals. West 1000D says we don't have to do that. We can take this data and we can reuse it across the board. So we write once, use many. And now we can follow the same logic through the S2000M. This is providing our materials support. So one of the advantages of structured data, particularly and specifically around predictive maintenance or preventative maintenance programs, is now this can also drive my supply chain requirements. If I know what's going to happen in the field through a certain set time, now I can give that information back to the supply organization, and now that can drive the demand. So if I have an operator who's going to be working close to in dusty environments and they're going to need more air filters, now I can start operating and starting to organize my data that way. S3000L, just to give a quick overview, that is where our logistics support analysis and activities are coming from. S4000P is preventative maintenance. This is simply a top-down FMEA analysis on how do we stop a functional failure in the field. How do we mitigate that? And we do that and one of the ways we can do that, or through the in-service optimization, is through the application of S5000F. So this is our feedback loop. How are we directing the data coming from the field? How can we structure this so it, again, it's accessible and it's actionable, right? And then, it's not on that slide, it's on my slide. There's another one, it's 6000T, but the icon's really gross, so I didn't put it on here. And that's our training, right? So we can structure the training environment around the same way. So again, our training is all built off everything that we're doing. This is a digital thread. We're creating from the design organization all the way through. We can follow this around. Any questions? I was 30 minutes, that's not bad. No questions. It was that bad. All right. Well, no questions. If you guys want to talk about this or any integrated product support strategies, structured data, structured content, please reach out to me or any one of my colleagues at JANA. We have Don back here and also John Schmidt, who's here. So please, we'll have a table out there. Thank you guys for your time. Thanks for coming, and we'll see you next year.